today we're going to be having a look at trigonometry, in particular the sine ratio. Okay. Now the first key point is that it only works with right angled triangles. So we could have these in different orientations, so different ways of looking at them. So we can have a right angled triangle like that, where the right angle is on the bottom right. We could have that flipped, we could have it rotated so the right angle is at the top. There's loads of different ways that we can have a right angled triangle. Okay, key thing, always got a right angle. Now what we need to do is label the sides of this triangle. Now you might know from having a look at Pythagoras' theorem previously that the first side we're going to have is the hypotenuse. Okay, and we're going to label that h. Now the hypotenuse is the longest side of the triangle. It is the side that is opposite the right angle. Okay. The next one we're going to have a look at, we need an angle for. Okay, so we're going to take this angle here, and let's have this one here. And these are labelled as theta, so it's a Greek letter. Okay, and that just means an angle. It doesn't really matter which Greek letter, but in particular we usually use theta. Okay. Now to label the other sides, we're going to do it in relation to theta. So we're going to say that one of these sides is opposite theta, and we're going to call that O, and another one is next to theta, so adjacent, which we call A. So opposite is nice and easy. We just look at where the angle is and pick the side that's opposite. Adjacent, we've got to be really careful that we don't pick the hypotenuse. So the hypotenuse is already labelled. Do not touch that. We now need the other side. So the other side that is next to A, next to theta, is that one there. Okay. Now before we look at some examples, we need the actual sine ratio. So sine ratio, sine theta is going to be the opposite side divided by the hypotenuse. And we can actually draw this as a formula triangle. So in the same way in physics you might use speed as distance over time. Here we're going to have sine theta is opposite over hypotenuse. Okay. Right, let's look at an example. So first example we're going to have a look at is a nice standard right angled triangle. So our right angle is over here. We've got 30 degrees. We've got this length is 10 centimeters and this one is x. Our job is to find out the value of x. So first step, step one, we need to label the sides. So remember what we were just doing. We need to label the hypotenuse first. Then we need to label the opposite side, so opposite our angle theta, which is 30 degrees here. And now normally I'd say we'll label the side adjacent, so that's along the bottom. But we don't have a value for the adjacent side. We don't know, like the hypotenuse, that it's 10 centimeters, and we're not being asked to find it like we are with the opposite side that's labelled x. So I'm not interested, I'm going to leave that alone. Step 2, we need to write our equation. So this is using the sine ratio or the formula triangle, and in this case we're trying to find out what the opposite side is. So the opposite side is going to be h times by sine theta. Step 3, we now need to substitute our values into that equation. So O is the side x, h is 10 and theta is 30. Okay, so we've got x is equal to 10 times sine 30. Step 4, we need to calculate. So 10 times by sine 30, put it into a calculator, gives us 5 centimeters. Now there is one last really important step. Okay, that's a 5. We need to check our answer. So the hypotenuse, which is 10 centimeters, is the longest side of the triangle. So if we're looking for the length of another side, it's going to be smaller than 10. 5 is smaller than 10. It also needs to be in the same sort of ballpark. Okay, this isn't a mad triangle where we've got like 1 degree and a million miles in the hypotenuse. This is a nice sort of standard triangle, so that distances, the two lengths, should be about the same. So 10 and 5, it's about the same, so that sounds good to me. Okay, let's have a look at one more example. So this time we're going to be doing it the other way round. Rather than trying to work out what the opposite side is, we're going to look for the hypotenuse. It's also going to be a slightly different triangle, have a bit more stretched that way. So we can have an angle this time of 36 degrees. We have x and 7 centimeters. If you want to pause here and have a go, feel free, and I'll be going through it in a second. Okay, step 1, we need to label the sides. So hypotenuse, opposite side, and we're not dealing with the adjacent here. Step 2, we now need to write out the equation. So h is O over sine theta. Step 3, we need to substitute. So x is 7 over sine 36 degrees. Next step, we need to calculate, and I've rounded this to 1 decimal place, so 11.9 centimeters. Last step, we need to check our answer. We've got 7 centimeters on the bottom. Our hypotenuse should be longer than that. 11.9 is longer than 7, but it's not a lot longer, so it seems in the same realm, so I would say yes, correct. Okay, here are 4 questions for you to have a go at. Pause the video now, work through them, and then replay the video, and I will put the answers on. Okay, let's go through some answers. So the first one, we are going to have x is 16 centimeters. With the second one, you might have an answer given as 10 square root 3 or 17.3 centimeters, depending on what calculator you've got and what it comes up with. Question 3, x is going to be 3 root 2 or 4.24 in the centimeters. And the last one, x is going to be 2.74 centimeters. Very well done if you've got those right. If not, go back through, try and work through them until you get to the right answer. Thank you for watching.